Hi, in today's tutorial, we'll learn more on partial fractions and we will focus on the denominators in the form of repeated linear factor. So examples, denominator with repeated linear factors, shown in example A here. So why do we call it as repeated linear factor? It's because we have this term x plus 5 bracket squared. This means that x plus 5 is repeated twice. And then we have one other factor, which is linear x minus 3. So how to separate this by using partial fractions? To separate this, you just have to write down the factors one by one. One of the factor is x minus 3, the other factor is x plus 5. But notice that since x plus 5 is squared, we cannot just write x plus 5 power 1 here. Then it will be the same. So the other fraction should be x plus 5 squared, because this shows that x plus 5 is one of the repeated linear factor. What if we have x squared? This also means the same thing. This means that x is repeated, so we have to write x and then x squared as the repeated factor. The other factor at this denominator is 3x plus 5, so we also write that as the other fraction. And then what should we write as the numerator? Remember that the numerator should be 1 degree less than the denominator. So since our degree of the denominator is linear, so the numerators must always be constant. Even though x plus 5 is bracket squared, but this just means that it's a linear factor, repeated. Also the same for x squared. X squared is the repeated linear factor of x. So that's why the numerator for x squared is also a constant. Same for 3x plus 5. 3x plus 5 is linear, so the numerator is constant. Look at example 1. This is the polynomial, write it down, x plus 2 bracket squared. First step is to identify what type of denominator this polynomial has. Now, the denominator for this polynomial is x plus 2 bracket squared. So this is a repeated linear factor. And how to separate repeated linear factor is we will have two fractions. One of the fraction is just the first linear factor. The other one is the repeated linear factor with the square. And what will be the numerators? Numerators will always be the constants if the denominator is consisted of linear factors or repeated linear factors. Next step is to compare the numerators. But to compare the numerators, we have to equate or equalize the denominator. Remember, in the previous tutorials, I have showed you how to multiply a with the other denominators, which is by ignoring the denominator under a and just multiply it with the other denominator. But that's not how you should do it for this type of fractions, because now we have repeated linear factors. So please remember this step carefully. What you should do is like this. Look at the denominator under a. It's x plus 2. So this means we also have to delete x plus 2 at our denominator on the left hand side. Okay, so since x plus 2 is one of the factor here, and now on the left hand side we have x plus 2 bracket squared, so we have to just delete one of the factor. So what's left is just x plus 2. So you have to multiply with x plus 2 with a. What about b? Look at the denominator under b. It is x plus 2 bracket squared. So that means we also have to delete x plus 2 bracket squared on the left hand side. Notice that there's nothing left. So that's why b We don't have to multiply with anything. Then just write down the numerator on the left hand side. And now, what's the best choice of your x? Same as the previous tutorial, look at the denominator on the left hand side. So the factor here is x plus 2, equate it to 0, and your answer is x equal to negative 2. So that means we just have to substitute an x equal to negative 2 into this line. Remember, one of the term of constants must equal to 0. So negative 2 plus 2 is 0, so it goes, and you're left with b. So b is equal to negative 2 times 7. You have found your b. Now to find a. Look at your denominator on the left hand side. Is there any other factor left? Well, there's no other factor. The only factor that we have is x plus 2 bracket squared. And we have used the answer, which is x equal to negative 2. We have used the value of x. To find a, we need one more answer of x. So what would that value of x be? Please remember this step. You can choose any value of x and please substitute the constant values that you have found. For example, for this question, the constant value that you have found is b equal to negative 14. So you can choose any value of x except for the ones that you have used. For example, x equal to negative 2 for this question. So you can choose any number except for negative 2 because you have used it. Okay? So you can choose, for example, the easiest value is 0. Substitute in 0 into the x. And after that, for b, since we have found the value, you can just straight away write the value of b, which is negative 14. And then solve this. On the left hand side is 0. This is 2a minus 14. Bring 14 to the left hand side, positive 14. So a is just 14 divided by 2, 7. The question wants you to write in partial fractions, so remember to write them in these two separated fractions. Write down your a and then your b. And copy down the denominators. So remember that if we have a negative sign here, you have to multiply that negative with the positive sign in front. So negative times positive is just negative. So change the sign in front here as negative. And that's your final answer. Now let's look at example 2. How to separate this polynomial. Okay, please identify. First step is to identify your denominator. Look at the first term of your denominator. It's x squared. So x squared, remember, is a repeated linear factor. Because x squared simply means that it is x minus 0 squared. So this is a repeated linear factor. But since we don't write x minus 0, we just write x, that's why it's just x squared. So remember the steps for repeated linear factor. Separate this x squared first. So x squared, the first one, you have to write x power 1. The other one is the repeated linear factor, x squared. And then the other factor, which is x plus 2, is just linear, so we can write x plus 2 as one of the denominator for this fraction. And then remember, x power 1 is linear, so the numerator must be constant. X power 2 is not linear, but it is a repeated linear factor, so the numerator must also be constant. X plus 2 is just a linear factor, so the numerator must be constant. Next, we have to compare the numerators by equalizing the denominator first. So to equalize the denominator, we have to multiply the denominators for each of the fractions with the other factors. Now look at the denominator under a. It's x power 1. So that means we have to look at the denominator on the left hand side and delete delete the denominator on the left hand side. So x power 1, to delete that, this is x squared, so you take 1 of the x from x power 2. So what you left is x power 1. So this means you have to multiply a with what's left, which is x times x plus 2. Also the same for b. Look at the denominator under b. It's x power 2. That means we have to delete x power 2 of the denominator on the left hand side. So when you delete x power 2, what's left is x plus 2. So you have to multiply b with x plus 2. Like this. And then the last one is c. For c, you also have to look at the denominator under c, which is x plus 2, and then delete x plus 2 on the left hand side denominator. So when you delete x plus 2, what's left is just x squared. Multiply c with x squared. And then you're done. Compare with the numerator on the left hand side. Remember your tips, do not expand. Please don't expand. Because if you don't expand, it's easier for you to calculate. Okay, so next, what will be the next choice of our x? Look at the denominator on the left hand side. The first one is x squared. So this is just x equal to 0. So substitute x equal to 0 into this highlighted yellow line. After you have substituted 0 in, make sure 2 of the terms will be 0. So 0 times a is 0. 0 times c is also 0. So what's left is just b times 2. Left hand side is just 1, so b is equal to 1 over 2. And then what's our next choice of x? Look at the denominator on the left hand side, equate it to 0, so your next choice is negative 2. Substitute in negative 2. After that, negative 2 times 2 is 0, so everything goes. Negative 2 times 2 here is also 0, so this goes, and you're left with 4c and negative 3 on the left hand side. So c is equal to negative 3 over 4. What's the last value of x that we should substitute to find the constant a? Look at the denominator on the left hand side. We have used x squared and we have also used x plus 2, and there's no other factors that we can substitute in. So what do we have to do once we have run out of the values of x? Same as in example 1. Remember these notes. You can choose any value of x except for the ones that you have used and substitute the constant values that you have found. So you can choose any values of x. So you have used x equal to 0 and you have used x equal to negative 2. So the other number, which is easy, and besides these two numbers, is, for me, would be 1. So you can simply substitute x equal to 1. But remember, you must also substitute the constant values that you have found. This means you have to substitute in the values of b and also c. Substitute the b, c, and also x equal to 1 into the highlighted yellow line here. Notice that I have substituted the values of b, replacing this b and also the c. Then simplify this and you will find your value of a is 3 over 4. Your final answer must be written in partial fraction, so don't leave your answer just like that. Please substitute a, b, and c into the ones that you have separated here. Write down the denominators and then write down the numbers of a, b, and c. So a is 3 over 4, write 3 on top and 4 below. B is 1 over 2, write 1 on top and 2 below. And c is negative 3 over 4, write negative 3 on top and 4 below with a bracket in front. Okay, but there's a negative times positive there. So what you have to do is, you have to multiply that negative value with the positive. So it's negative and then just write 3 there. So that's your final answer. Now, same method applies as in example 2 to solve example 3. Try it out. Also try out example 4.